Now, whenever you confront log or tan inverse or say cot inverse, such functions, invariably you will have to differentiate, because unless you do that, you will not get an expression in terms of yes. And finally, take the inverse Laplace transform, and whatever you get, divide that by t, because unless you simplify this and then differentiate, even while seeking the inverse Laplace transform, it becomes difficult. Now let's look at one typical problem which requires differentiation. In fact, in the previous video, we proved that why you should multiply the resulting expression once you differentiate this particular expression by -1. That also must be borne in mind. Now, whenever you confront log or tan inverse or say cot inverse, such functions, invariably you will have to differentiate, because unless you do that, you will not get an expression in terms of yes. Okay, it becomes a function of log or function of a trigonometric function, which is not possible for you to get the inverse Laplace transform of. So what are the steps involved? First thing is you'll have to simplify this. The second step is to differentiate, because you cannot differentiate as it is, because you may find this differentiation cumbersome. And once you differentiate, whatever result you get, you'll have to multiply that by minus, and then finally get the inverse Laplace transform and divide that by t. Why exactly that is important? That is because you got an expression either of log or tan inverse because you integrated the Laplace transform. That means you should have had a function of this form, f of t by t. This is very, very important for you to observe. Whenever you get the Laplace transform of a function like this, then only it is possible to get a logarithmic expression or a trigonometric expression, depending on the nature of integration, right? For example, for cos you get a log function, for sine you get a tan inverse function. So therefore, unless you do the integration, you cannot get this function. So when you differentiate, you multiply the resultant derivative by -1, and once you did that, you take the inverse Laplace transform, and once you get the inverse Laplace transform, you divide that by t. So therefore, in general, what you will get? You will get inverse Laplace transform of negative of d by ds of whatever function you are given. Let us say this to be g of s function, and then you would finally divide this by t. Finally divide this by t, so that you get your inverse Laplace transform. So what are the steps involved? First, simplify this, differentiate this, take the negative of that derivative, and finally take the inverse Laplace transform, and whatever you get, divide that by t, because unless you integrate the Laplace transform, you cannot get a log function or a tan inverse function. So therefore, it is obvious. So let's try and do this systematically. So I cannot differentiate this straight away, because it will become complex, and also unless you simplify this and then differentiate, even while seeking the inverse Laplace transform, it becomes difficult. So I would use the basic algebra of logarithms, and remember the following rules. Though it is very trivial, let me write it for you, because sometimes you may get confused as a beginner. Log a minus log b. And also remember, if you have log of a, b, c, that is simply equal to log of a plus log of b plus log of c. All right. So these are the two rules I'm going to employ in order to simplify this expression. So this is going to be rewritten as log of s square plus 4, because a by b, see a by b, I'm going to write it as minus log of s into s plus 4 into s minus 4. That was a basic logarithmic algebra for you. And then finally, how would I simplify? Since this has the same form log ABC, that's going to be split, and that is going to be expressed as log of s square plus 4 and minus, since it can be sum of log of s plus 4, log of s minus 4, this is going to be minus log s minus log of s plus 4 and minus log of s minus 4, right? So that this expression first simplified to this and then to this. Now what is step number 2? Once you simplified, you go for differentiation. So if I differentiate a log function, always remember you get the reciprocal of the log function, and then you will have to differentiate the function inside. So what you will get here is if I differentiate s square plus 4, I get the reciprocal first, and then I differentiate the function inside, that is s square plus 4, and that becomes 2s. Am I right? So what about the next one? It's going to be 1 by s, because if you differentiate s with respect to s, you will get 1, so you will continue to get 1 in the numerator. And same is the situation for s plus 4 and minus s minus 4. So now basically you see that this term which was in the numerator continues to be positive, and the terms which are in the denominator continue to be negative. That is simply attributed to the logarithmic algebra. Now the next step is, first step I simplified, second step I differentiated. The third step is to take negative of this, as we wrote the formula here. You will have to take the negative of whatever you got on differentiation, and therefore my next expression would be negative of that would mean 1 by s plus 1 by s minus 4 plus 1 by s plus 4 and minus, so what I got as the positive expression, 2s by s square plus 4. So step number 3 is also complete. Now I will have to take the inverse Laplace transform, and whatever I get, I will have to divide by t, because only when you integrate whatever we are going to get, the Laplace transform of whatever we are going to get, that this expression could be got. So therefore what we will have to do, we will have to take the inverse Laplace transform of this, and then finally divide whatever expression you get by t to get your final answer. So 1 by s, if I take the inverse Laplace transform, what you would get? You will get a constant 1, because you observe this carefully, we have done this several times. 0 to infinity, Laplace transform of any function is e power minus st multiplied by that function, 1 in our case, and integrate with respect to t. This is equivalent to integrating only the exponential function, which turns out to be e power minus st by minus s. And since the exponential function has a negative term, and the top limit being infinity, that goes to 0, and the bottom limit when you put t is equal to 0, e power 0 is 1, and since you subtract the result of top limit from the result of bottom limit, that is 0, from that of the top limit is 0, and since there is a minus, minus of minus becomes plus, and that becomes 1 by s. Just to reiterate, and this you very well recognize that once you get this result is got by frequency shifting. Since it is minus, the frequency shifting that you want to suggest here is 1 into e power plus 4t, because it is minus here. If it were plus, the frequency should have been the exponential term should have been e power minus 4t. And similarly, what you get here is also e power minus 4t, and then what you get for this is very, very simple. Whenever you get s in the numerator and divided by s square plus 4, this is nothing but the Laplace transform of cos, and if you don't get s, it would have been the Laplace transform of sine. Now you can take 2 as a constant. S by s square plus 4 is nothing but the Laplace transform of cos. You remember the differential equation of a spring mass system, where we assumed the initial velocity to be 0 but displacement to be maximum. There we could get the definition of cos, and therefore this is easily written as cos of 2t, because here you can see here square, because the general expression for Laplace transform of cos is s divided by s square plus a square, and a is 2 here. So cos at, this is for cos at Laplace transform, and therefore you got s square a square here. So that this a square is nothing but 4, which is nothing but 2. A is nothing but 2. So this is what exactly you get. This is what exactly you get as the inverse Laplace transform of this, because 1 by s inverse Laplace transform we have explained, that is 1, and 1 by s minus 4 inverse Laplace transform is 1 into e power 4t, and 1 by s plus 4 inverse Laplace transform is e power minus 4t, and 2 can be taken as constant. S by s square plus 4 inverse Laplace transform is cos 2t. So this is done. So once this is done, what is my next step? The next step that I have to get my answer is f of t by t, and that is given by 1 by t plus e power 4t by t plus e power minus 4t by t minus 2 by cos 2t by t. Now does it make sense? Because if you want to find 1 by t, you will have to integrate 1 from s to infinity, and that is where you get log of 1 by s. And if you want to find this, you will have to integrate e power 4t from s to infinity. If you want to find e power minus 4t by t, you will have to integrate from s to infinity, that is e power minus 4t. And similarly, cos 2t, you will have to integrate this particular expression, s by s square plus 2 square, of course, in this case, from s to infinity, then only you will get the log terms. So it makes complete sense now. This is your final answer. So I can square bracket it, and let us once again understand what exactly we did. So what was the problem? The problem was simple. You were given a log function, and how do you get a log function? Whenever you get a function integrated, that is the Laplace transform of a function integrated from s to infinity. When do you do that? You do that whenever you have this particular form, So therefore, once you find f of t, obviously you will have to divide by t, because the Laplace transform of f of t, when integrated, you will get this form, right? So what you should do, we also proved in our previous discussion that whatever you get on differentiation of this function, in order to get rid of log, you will have to multiply by minus. Why are you differentiating? Because you integrated. To undo it, you will have to differentiate. Okay, so we have differentiated it and multiplied by minus, and then finally divide the answer by t, and that is what exactly we have followed. First, before differentiation, we used these laws of logarithmic algebra. Log of a by b is log a minus log b. Log of abc is log a plus log b plus log c. And when I implemented that, I got log of s square plus 4 minus log of the denominator term, and the denominator term is of this form, so I could split that into 3 terms. And then I differentiated. Whenever you differentiate a log function, you get the reciprocal, and then the function itself has to be differentiated. So only for the first one you had to differentiate the function. For rest of all terms, the function is just of s power 1. That means when you differentiate, you continue to get 1. And even s does not have any coefficient, it has coefficient 1. So all the numerators continue to be 1. And once this is done, what happens? We have to take the negative of the expression. You can see all the expressions pertaining to the denominator were negative. The expression pertaining to the numerator was positive. So therefore, when I took the negative of that expression, rest of the expression, that is all the expressions pertaining to the denominator, became plus, and the one pertaining to the numerator became minus. And taking inverse Laplace transform was very easy. 1 by s means 1, because I proved that here when you take the Laplace transform of 1, with e power minus st and infinity being the top limit, you get 1 by s, and that is where 1 by s is replaced by 1. And 1 by s minus 4 would mean it is 1 into e power 4t, because you are frequency shifting by plus 4. And the same is for s power s plus 4, because you are frequency shifting by minus 4. And what about this? This is 2 into, this exactly fits into the definition of Laplace transform of cos, and this is what exactly you get. And finally, since you differentiated it, and you know that only when you integrate the Laplace transform of these functions, you will get the log function, so you had to divide by t. So for example, if you want to verify whether you have got the correct answer, what you can do is you can find the Laplace transform of all these terms and simplify. How do you do it? You know the procedure. Just take the Laplace transform of 1, which is 1 by s, then integrate that with respect to s from 0 s to infinity. What is the Laplace transform of e power 4t, which is nothing but 1 by s minus 4? Again integrate that, and again 1 by s plus 4, again integrate that from s to infinity. And you know the Laplace transform of cos 2t, s by s square plus 4, integrate that from s to infinity and simplify. You should get back to this particular term. Okay, you can do that exercise, but this is the established procedure. Whenever you get a trigonometric function, log function, differentiate it, take the negative of the derivative that you get, and then find the inverse Laplace transform, and then divide the entire expression by t. And that is what exactly you are expected to do. So let's move on and look at the next discussion. Well, engineering and math are absolutely inseparable. We interventions day in and day out try our level best to make math as simple as possible and also of great practical value to every aspiring engineer. Do you want us to reach the masses? Please like us, share and subscribe. Do not forget to turn on the bell icon.